that is in the 8th standard. Already we studied about the polynomials, then the degree of polynomial, then the types of polynomials, and some of the operations of the polynomials, as well as the products of polynomials. Also, we studied the factors of polynomials, but in this standard we have to study polynomials in deep. Students, today we are going to study about the polynomials. In this chapter, we have to study some of the important points like introduction to polynomials, then degree of the polynomials, value of the polynomial, then operations on polynomials, synthetic division, and remainder theorem. So these are the some of the important points in this chapter which we have to study. So friends, first we have to study what is the polynomial. Already we studied in last standard, but again we have to revise it. There are different types of algebraic expressions. In these expressions, for example, y plus 1 upon y, this is an algebraic expression, as well as 2 minus root 5x. This is also an algebraic expression. Then x square plus 5x plus 2, then 17, then m cube minus 2m square plus 5m minus 1. All these are some of the algebraic expressions. Now from these expressions, as well as one of the example, 2x raised to minus 2 plus 3x plus 2. So these are some algebraic expressions. All are the examples of algebraic expressions, but all are not polynomials. It means that some of the algebraic expressions from these are the polynomials and some are not polynomials. Then what is the definition of polynomial? Here the definition of polynomial is given in an algebraic expression. If the powers of the variables are whole numbers, it is very important. In an algebraic expression, if the powers of the variables are whole numbers, these powers should be whole numbers. So find the given powers are either whole numbers or not. Here in an expression, the first expression y plus 1 upon y. By solving this, we get y plus y raised to minus 1. Y plus y raised to minus 1. Suppose this example is given as 2 minus 5 root x. By solving this, we get 2 minus 5 x raised to 1 upon 2. X raised to 1 upon 2. Square root of x. Then here x square. By solving this, x square plus 5x plus 2. This is an expression 17. Then here by solving we get as same. Then here by solving we get same. Now study these examples. The powers in an algebraic expressions, the powers of the variables are whole numbers. Variables, here y is a variable. In this example, x is a variable. Here also x is a variable. Here there is not variable, means this expression or this term is called as the constant term. Here the variable is m and here the variable is x. So if the powers of the variables are whole numbers, here minus 1 is not a whole number. You know the set of whole numbers. Set of whole numbers, that is W, which starts from 0. First whole number is 0, then 1, 2, 3 and so on. So in the set of whole numbers, these are the numbers. And minus 1 doesn't include in W. It does not include in this set, in the set of whole numbers denoted by capital W, W for whole. So minus 1 is not a whole number. Therefore, given expression is not a polynomial. Is not a polynomial. Then decide about second example, second expression 2 minus 5 by using the law of indices. Here there is a square root of x. So we write it as 2 minus 5 into x raised to 1 upon 2. But in this example also, friends, this power 1 upon 2 is not a whole number. It also doesn't include in this set. So it is also not a whole number. Therefore, the given expression is not the polynomial. In this example, the powers 2, 1 and 0. The powers 2, 1 and 0. 2, 1 and 0. All are found in the set of whole numbers. It means that the powers of variables are whole numbers. Therefore, this expression is a polynomial. according to the definition of polynomial, this including the polynomial. Then power of 17. Power of 17 is 0, which includes in the set of whole numbers. That means 17 also a polynomial. Then decide about this example. The powers are 3, 2, then 1 and 0. All are found in the set of whole numbers. That means the powers of the variables are whole numbers, and therefore according to the definition of polynomial, the given example or given algebraic expression is a polynomial. Then decide about this last example. Variable x, the powers are -2, 1 and 0. Out of these, -2 does not include the set of whole numbers, and therefore according to the definition, this example or this algebraic expression is not a polynomial. Yes, is it clear? So, next point. Now friends, we have to study about the types of polynomials. Types of polynomials based on number of terms. There are different types of polynomials. First type, which is based on the number of terms given in the polynomial, and other type of polynomials is the polynomials which are based on the degree. Let us study about the types of polynomials based on number of terms. Friends, there are three types of polynomials based on number of terms. First one is the monomial, in which polynomial only one term is given. If there is only one term is given in the polynomial, then that polynomial is called as a monomial. For example, there are three examples of monomials, or separate examples. 5x is a monomial. 2y is also a monomial, or 3 is also a monomial. Other examples, 10y square is a monomial, or 7x raised to 5 is also a monomial, or 1/2 is also a monomial. So these are the examples of monomials. There is only one term in the polynomial. So these are the monomials. Then second type based on the number of terms, that is the binomial. Bi means 2. So there are two terms in the polynomial. For example, first one is the m square plus m. Second example, a square minus 5a. There are two terms. M square is the first term and m is the second term. Here a square is the first term and minus 5a is the second term. Or here p cube minus 3p is also a binomial. There are two terms, first term and second term. Only two terms are given there. If there are two terms in the polynomial, then the polynomial type of polynomial is a binomial based on the types of terms. There are two terms. Similarly, the third type of polynomial, which is based on the number of terms, is a trinomial. Tri means three. Tri means three. Trinomial. If in the given polynomial there are three terms, then it is a trinomial. For example, 1 upon 2p square minus 2p plus 7. This is the first term. 1 upon 2p square is the first term, minus 2p is the second term, and plus 7 is the third term. There are three terms. So, this polynomial is a trinomial. Then, other example, x cube minus root 3x square plus 5x. First term, minus root 3x square is the second term, and plus 5x is the third term. It means that in this polynomial there are three terms, therefore it is a trinomial. And then if the number of terms in the given polynomial is more than 3, we say them as a polynomial. Then we have to study about the polynomials. Here the polynomials are written as px or qy or rz or sm. Friends, here p, q, r and s for polynomials, and the letter which is shown in the bracket, that is x, y, z or m, are the variables of such polynomial. For example, px, here polynomial in x variable, that is 5x cube minus 3x square plus x plus 2. This is the polynomial. So p for polynomial, x for the variable which is used in that polynomial, or qy. Suppose here y raised to 5 minus 2y raised to 3 plus 5y minus 6. Here q for polynomial and y is the variable given or used in such polynomial. So p, q, r, s are shown for the polynomials, and x, y, z or m. Such letter shows the variables given in the polynomials. Then students, we have to find next point, degree of a polynomial in one variable. Degree, next point, degree of polynomial in one variable. The definitions are different there. Degree of polynomial is one variable and degree of polynomial in more than one variable. There are two types of polynomials. Polynomials in one variable and polynomials in more than one variable. So first we have to find the degree of the polynomial in one variable. Now, you know the degree of polynomial in the previous standard. We studied the degree of the polynomial, the highest power of the variable. The highest power of the variable is called the degree of the polynomial in one variable. Highest power. For example, some of the examples: m cube minus 2m square plus m plus 1, then x raised to 5 plus 5x raised to 4 plus 3x2 minus 2 or y2 minus 1 or 2p square minus 3p minus 5 or only 5 or root 7 are some of the examples of the polynomials, and we have to find the degree of all these polynomials. All polynomials are in one variable. Note this point. For example, m is only one variable used in this polynomial. Now the highest powers are 3, 2, m raised to 1 and 1 raised to 0. Power of 1 is 0. Here 5, 4, 3 and 0. Here powers are 3 and 0. Here powers are 2, 1 and 0. Here powers of these examples are 0 both. So the highest power of the variable out of these 3, 2, 1 and 0, 3 is the highest power. So this is a degree. 3 is the degree of this polynomial. In case of this second polynomial, 5, 4, 3 and 0, out of these 5 is the highest. Therefore, degree of this polynomial is 5. Then here 3 and 0 are the powers. Out of these two, 3 is the highest. Therefore, 3 is the power or highest power. That means 3 is the degree of the given polynomial. Then decide about this polynomial 2, 1 and 0. 2, 1 and 0 are the three powers of three terms. Out of these three, 2 is the highest power, therefore 2 is the degree of the polynomial. Here both are constant terms. But root 7 is a constant term. Root 7, there is no variable. The terms which are given without variables means the value of the terms is constant. It doesn't vary. The value of these terms doesn't vary, doesn't change. That means the values of these types of polynomials are constant. So we say them as constant polynomials, and degree of constant polynomial is always 0. Degree of non-zero constant polynomial, non-zero. This is also most important. Degree of non-zero constant polynomials is always 0. Therefore, the degree or powers of these two polynomials are 0. So, the degree of this polynomial is 0. Degree of this polynomial is also 0. This is about degree of the polynomial in one variable. Then, the next point, degree of the polynomial second type of polynomial, degree of the polynomial in more than one variable. In more than one variable. For example, study first the example of the polynomial. Here the example of polynomial is given. X square y cube plus x square y square minus xy. This is the first example. Then second example, study about 3 m cube n cube plus 6 m cube n square minus 5 m square n square minus 2 m. Such types of third example, x y z minus x y plus z. These are some of the examples of the polynomial in more than one variable. More than one variable. Study here x and y are the two different variables. That means variables are more than one. Two variables are there. Here also in second example, m and n are the two variables. In the third example, x, y and z are the three different variables. That means the variables are more than one. Now let us study the degree of the polynomial in more than one variable. Here the definition of the degree of the polynomial, the highest sum, the highest sum of the powers of variables is called as the degree of the polynomial is more than one variable. The highest sum, students, listen carefully, see here carefully, the highest sum of the powers, for example, these are the powers, 2 and 3 are the powers of two different variables. So 2 plus 3 equal to 5, 2 plus 2 equal to 4, and 1 plus 1, here powers are 1 plus 1 equal to 2. Then the highest sum of the powers 2 plus 3, that is 5, 2 plus 2 4, 1 plus 1 2. Here the highest sum is 5. Highest sum of the powers is 5. Therefore, the degree of this polynomial is 5. Here degree is 5. Now study the degree about this example, this polynomial. Here sum is 3 plus 3, 6, 3 plus 2, 5, 2 plus 2, 4, and 1 plus 1, that is 2. Out of these, the highest sum is 6, therefore 6 is the degree. If we change, for example, 3 m raised to 5 n raised to 3, then highest sum is 5 plus 3 equal to 8. Not product, sum. Highest sum. Highest sum is 5 plus 3 is equal to 8. Therefore 8 is the degree of this polynomial. And then here 1 plus 1 plus 1, here 1 plus 1, here 1. So highest sum 1 plus 1 plus 1. Sum 3, sum of these 2 is 2 and here 1. So out of these 3 is the highest sum of the powers of the variables. Therefore the degree of this polynomial is 3. So these are some examples of degree of the polynomial in one variable and degree of polynomial in more than one variable. So you have to solve the examples from the practice set 3.1. Question number 1 for you, also question number 4, and question number 1 and question number 4. These two questions are for you. So solve all these all the sub questions from these two questions. Okay, we will stop here. Thank you.